This world is not what you think it is. This world is not what you think it is.
We still have flat earthers. We have people that don't believe in vaccinations. And what do we do about it? Well, first of all, I think there's a gene. I think there's a gene for superstition, a gene for hearsay, a gene for magic, a gene for magical thinking. And I think that when we were in the forest, that gene actually helped us. Because 9 times out of 10, that gene was wrong. Superstition didn't work. But 1 time out of 10, it saved your butt. That's why the gene is still here. The gene for superstition and magic. Now, there's no gene for science. Science is based on things that are reproducible, testable. It's a long process, the scientific method. It's not part of our natural thinking. It's an acquired taste. It's like broccoli. You have to learn how the power can be unleashed by looking at your diet, for example. So I think 1,000 years from now, 1,000 years from now, we will have flat earthers.
There is a crisis in cosmology. Usually in science, if we're off by a factor of 2 or a factor of 10, we call that horrible. We say something's wrong with the theory. We're off by a factor of 10. However, in cosmology, we're off by a factor of 10 to the 120. That is 1 with 120 zeros. This is the largest mismatch between theory and experiment in the history of science.
How do we know the Earth is not flat?
We don't.
We are prisoners on Earth.
It's flat.
Space station taunts us by showing us all the places we can't ever visit. However, if our species wants to have a long-term future, we have to escape our prison. But what's keeping us here in the first place, alive? Turns out, we owe the universe a debt. Gravity, the line. This effect traps us prison. We can imagine this as stories to describe the world. We test our stories and look at reality up close.
It's flat.
And we're amazed. Wondrous landscapes in the dust. We test our stories. We test our stories. We test our stories. And we're amazed. We test our stories. We test our stories. We test our stories. And we're amazed.
The science delusion is the belief that science already understands the nature of reality in principle, leaving only the details to be filled in. This is a very widespread belief in our society. It's the kind of belief system of people who say, I don't believe in God, I believe in science. It's a belief system which has now been spread to the entire world. But there's a conflict in the heart of science between science as a method of inquiry based on reason, evidence, hypothesis, and collective investigation, and science as a belief system or a worldview. And unfortunately, the worldview aspect of science has come to inhibit and constrict the free inquiry, which is the very lifeblood of the scientific endeavor. Since the late 19th century, science has been conducted under the aspect of a belief system or worldview, which is essentially that of materialism, philosophical materialism. And these sciences are now wholly owned subsidiaries of the materialist worldview.
Several decades ago, we found a problem so great that it was brushed under the carpet for many a decade. And this is the fact that galaxies spin too fast. We believe in the work of Isaac Newton, at least on planetary scales, but when you apply Newton's laws of motion to the galaxy spins too fast. In fact, 10 times too fast. By rights, the galaxy should fly apart. Therefore, scientists said that we have to have dark matter, a halo of matter that surrounds the galaxy and holds the galaxy together.
Between 1% and 3% of the universe is all the stuff we can see, and somewhere between 99 and 97% of the universe is stuff we can't see. This dark matter that dominates our galaxy, we think, we're virtually certain now, is made of some new type of elementary particle, different than the stuff that makes you and I up.
And what have they discovered? Absolutely nothing. Zilch.
What is a little bit perturbing is that after 50 years we still haven't found what the dark matter is. But on the other hand, that doesn't mean they're not there, it just means they're harder to find than we thought.
We look out in the universe and 85% of all the gravity that's out there has some mysterious unknown source. We add up all the stars, the galaxies, the planets, the comets, the black holes, the dark clouds, everything out there that we can see, touch, smell, or taste. And it doesn't add up to give us the gravity that we see operating in this universe. So really we should be calling it the dark force, because we don't know if it's made of matter. It could be a profound misnomer, sending people off in thought directions that might not really be the right path. So dark matter is just simply what we call this thing about which we know nothing, responsible for 85% of the gravity of the cosmos. We've known about dark matter since the 1930s. Back then it was called missing mass. That's what it was called. Because, yeah, there's got to be some mass. Where is it? We can't find it. It's got to be here somewhere, because we got the gravity. If you have the gravity, you got to have the mass. Mass and gravity go together. It's really dark gravity. Actually, we shouldn't call it anything. We should call it Fred. Something that has no meaning, because we don't know what it is to call it. But it is the longest standing unsolved problem in modern astrophysics. Dark matter, dark energy. Everything we know about the universe, what we're made of, galaxies, stars, planets, that's all right here. So, according to this chart, we are 96% stupid.
So the problem with cosmology is that we keep inventing theories, ad hoc theories, to try to explain the data, such as inflation, dark matter, dark energy, and so on, just to keep patching the theory up.
There is a crisis in cosmology. Usually in science, if we're off by a factor of 2 or a factor of 10, we call that horrible. We say something's wrong with the theory. We're off by a factor of 10. However, in cosmology, we're off by a factor of 10 to the 120. That is 1 with 120 zeros. This is the largest mismatch between theory and experiment in the history of science.
This is the universe, home of the Whopper. I'm your host, Stephen DeGrasse Colbert. Yes. DeGrasse. Turns out you can't copyright a middle name. Here aboard my ship of the imagination, the Green Screen 5000. We are freed from the constraints of space and time using these controls: a warp field neuralizer and a hot glued speak and spell. We can travel anywhere our imagination leads us, as long as my graphics team can crank it out in an afternoon.
I'm Neil deGrasse Tyson, bitch.
So from nothingness comes somethingness.
Yes.
Okay.
And by the way, just to put you at ease with that,
please,
because the way you said that was all pejorative. Just want you to know.
It was. It had a little majority to it.
You copped a little attitude on
I did.
that.
I was like, and I wasn't really excited with the answer. I was like, it didn't really answer anything for me.
How do you get something from nothing? So let's say you have. Oh, let me save the answer to that.
Okay.
For after the break.
The answer to this, Mr. Bender, next week.
When we come back on Star Talk, we'll find out how you get something from nothing on this edition of Cosmic Queries, Everyday Astrophysics.
I'm Neil deGrasse Tyson, bitch.
So you've got questions?
I've got questions.
And it's on Everyday Astrophysics.
Yeah.
Bring it on.
I Actually, you left me hanging on the last. There was a big cliffhanger that we left on, and you didn't finish it for me.
Oh, I forgot.
And I almost forgot too.
Okay.
Because you greased me out of it.
Oh, yeah, I did. I said nice things about you. Hey, it's all about me.
Yeah. I was like, I'm listening.
So the question was, how do you get something out of nothing?
Mm-hmm.
So the thing is, with energy, you can have positive energy and negative energy. It's not just an emotional thing. It's actually a real physical thing in the physical universe. And each of those have consequences on space, time, and matter. But if you bring them together, it sums to no energy at all. So how does this happen? So think about it. Let's say there's level ground, and then I have a shovel, and I put ground from this part, and I stack it over here. So I'm digging a hole,
right,
and making a mound. Well, I can keep doing this, and I can have a hill as arbitrarily as high as I want, and I can climb to the top of the Empire State Building. But there's a hole next to it. So how did I get that high? How is that even possible? I took the dirt over here and I put it over here. But if I put the dirt back in, then everything's level again. So it's a way to think about what it means when you have negative energy and positive energy. There are a lot of things we do where you started with nothing, but you ended with something that you care about. But in the total picture, it sums to zero.
I see. That's good. See, now that's a good explanation.
That's what I'm saying.
That I can walk away with and go, okay, I get that.
And not lose sleep tonight. Good.
Yeah, I would have lost sleep. I would have been.
Neil deGrasse Tyson's explanation of the Big Bang and how you get something from nothing. Watch this man do his fake yawn. He knows Neil is just spouting out a load of crap.
And then I have a shovel, and I put ground from this part, and I stack it over here. So I'm digging a hole,
right,
and making a mound. Well, I can keep doing this, and I can have a hill as arbitrarily as high as I want.
I'm sorry, I'm allergic to bullshit.
But physicists who make up the laws of nature are less constrained by them than most of us. And in the 1980s, people who were studying galaxies found that the galaxies weren't behaving as they ought to. These stars in the galaxies were revolving around the center far too fast, according to the amount of matter there should be in the galaxy. And galaxies were attracting each other too strongly to be explained in terms of the total amount of matter within them. If you add up all the matter within them, stars, planets, gas clouds, make generous assumptions for invisible stars and so on, there's not enough matter to explain the gravitational pull of one galaxy on another, or of a galaxy on its outlying stars. So there was a terrible dilemma. What to do? Either the theories on which cosmology were based, Newtonian or Einsteinian relativity and gravitation, were wrong, or there was some organizing principle in galaxies over and above gravity that scientists had missed out. Or there must be a lot more mass that we couldn't see within the galaxies that could explain the missing gravitational effect. Well, the least disruptive assumption for scientists was that there was a lot more matter that we couldn't see, and because we can't see it, it was called dark matter. So they postulated that there was dark matter in the galaxies that would explain these phenomena. The distribution of dark matter could be adjusted for each galaxy to explain its shape and its behavior. How much dark matter did each one have? Well, the answer is simple. You just titrate in as much dark matter as you need to make the equations balance and explain the form of the galaxy. And that's the prevailing view. There are still minorities in science who think that there have to be other ways of thinking of galaxies or modifying gravitational theory, but the great majority take the view that dark matter is real. However, the problem with that is that there's not a shred of evidence for its existence. Despite billions of dollars being spent on dark matter detectors, underground pits full of fluids and so on, not a shred of evidence has emerged that it actually exists. The only evidence for it is that it makes the equations balance and enables the conventional theories of physics to survive any test, because you can add in more dark matter or subtract it as required to explain what you want to explain. It's basically an untestable theory. They've tried to test it, the tests have failed, but nobody's given up the theory because it fits the theories that they want to believe in. Now, this led to a serious problem, because having magnified the amount of energy in the universe by about 5-fold through dark matter, far more of it than regular matter, that meant the whole universe had far more gravitation than people had previously thought. And that would mean that the expansion of the universe, following the Big Bang, the expansion that's still going on, should be slowing down owing to all this extra matter within the universe. And in the 1990s, people thought that the universe would stop expanding, it would finally reach an ultimate limit, and then be pulled back together by all this matter in the universe gravitationally, until the whole thing ended in the opposite of the Big Bang, known in the trade as the Big Crunch. And the whole thing would end in tears. Well, that was the general view in the 1990s. But about 1999, observations of distant galaxies revealed that far from slowing down in their recession from us, they were speeding up. The universe was expanding faster and faster all the time, the exact opposite of the prediction of the dark matter theory. So, what to do? Well, again, you can't modify the fundamental assumptions because they're fixed. So, they did modify it in the sense that they said, well, there must be an extra form of energy pushing the universe apart, and we'll call that dark energy. And it's dark energy because it's undetectable by anything other than its effects, namely pushing the universe apart faster and faster. The problem is, this has now led to a tremendous problem for the principle of conservation of matter and energy, because the main theory of dark energy is that the density of dark energy is uniform throughout the universe and remains uniform. But since the universe is getting bigger, that means there must be more of it. So the universe is now a perpetual motion machine. It's actually creating energy as it expands. So, is the law of conservation of matter and energy valid? Physicists have made up matter and energy in the last 20 or 30 years till they made up matter and energy. Dark matter and energy is now 95% of reality. Can it be converted into regular matter? Could some matter suddenly appear in this room as a result of being transformed from dark matter or dark energy? Well, nobody knows, because no one knows anything about dark matter and dark energy. So we're left with this it's as if physics has discovered the cosmic unconscious. 95% of reality is utterly unknown to us, and yet it's pervading this room.
Through your career and your writing and your acting, you've inspired so many people to enter the sciences. How do you balance science with science fiction?
They're both the same.
Now, dark matter is not even what we should be calling it, because that implies that it's matter. It implies we know something about it that we actually don't. So a more precise labeling for it would be dark gravity. Now, if I called it dark gravity, are you going to say, does dark gravity really exist? I'd say, yeah, because 85% of the gravity has no known origin. There it is.
What is gravity?
You have no idea. Okay, next question.
Wow.
No, here's the difference.
Wow.
No.
I know. That's exactly what I wished for. Well, I actually wished for it 30,000 years ago.
It's true. Even at the speed of light, mean-spirited thoughts from the stars can take thousands or even millions of years to reach the Earth. Bitch, matter tells space how to curve. Space tells... Yeah, matter tells space how to curve. Space tells matter how to move. It's beautiful.
That is beautiful.
It is.
It sounds like the opening to a dance lesson. How do we begin?
Would be dark gravity.
I gotta say, you're totally blowing my mind right now.
That's what I do. I'm Neil deGrasse Tyson, bitch. There it is. I'm Neil deGrasse Tyson. Bitch.
Totally blowing my mind right now.
I'm Neil deGrasse Tyson. Bitch. Neil deGrasse Tyson. You don't see the curvature of the earth. If you are 2 millimeters above this beach ball, he just don't. That stuff is flat. I'm Neil deGrasse Tyson, bitch. There it is. It's beautiful. I'm Neil deGrasse Tyson, bitch. I'm Neil deGrasse Tyson, bitch. I'm Neil deGrasse Tyson, bitch. Neil deGrasse Tyson, bitch.
I gotta say, you're totally blowing my mind right now.
That's what I do. I'm Neil deGrasse Tyson. A more precise
onto the surface of the moon in a precise way. There is no capability to do that today.
There is no reference to what we think it is, because in fact, we have no idea. We live in a free country. In a free society, you ought to be able to think and say whatever you want. You can and should think whatever you want. If he wants to think Earth is flat, go right ahead. You want to think the world is flat? Go right ahead.
If some of these folks were around when Columbus set sail, these guys were around when Columbus set sail, they must have been founding members of the Flat Earth Society. They'd be charter members of the Flat Earth Society.
You must consider every available option and platform to meet our goals, including industry, government, and the entire American space enterprise.
Bitch.
History is written by those who dare to dream big and do the impossible.
We gotta dare to dream big, try to do the impossible.
Bitch.
History is written by those who dare to dream big and do the impossible.
Bitch.
We keep going. Whether it's the moon, an asteroid, Mars.
The moon, Mars, asteroids, there's a lot of destinations that we could go to.
Bitch.
The moon, an asteroid, Mars, sending unmanned robotic missions out to the moons of Saturn and Jupiter.
Bitch. Now, if I called it dark gravity, are you going to say, does dark gravity really exist? I'd say, yeah. There is no reference to what we think it is, because in fact, we have no idea.
As my friend Terence McKenna used to say, modern science is based on the principle, give us one free miracle and we'll explain the rest. And the one free miracle is the appearance of all the matter and energy in the universe and all the laws that govern it from nothing in a single instant.